Welcome everyone. What we're going to do today is we're going to write what is called a molecular equation, a complete ionic equation, followed by a net ionic equation. Now the example that I'm going to use here is a precipitation reaction, which is a double replacement reaction. Now this question has 4 parts to it. On this page, what we're going to do is Part 1 says to write the complete molecular equation and then afterwards balance if necessary. You are given here that sodium hydroxide is reacting with copper 2 chloride and we have to predict the products. Now, as a double replacement reaction, you'll see sodium is Na, it has a +1 charge. Hydroxide is a polyatomic. It has a -1 charge. When you crisscross these two, you get NaOH. It's reacting with copper 2 chloride, so copper has a +2 charge. Chlorine or chloride has a -1 charge. So when you crisscross these two, you get CuCl2. Now, what we're going to do is, if you follow a double replacement reaction, remember that you got a metal and a nonmetal in this case reacting with another metal and a nonmetal. And one of the things you could do is you can use like foil where the outers are going to get together. So A and Y will get together and the two inners will get together. Since the metals are written first, we're going to write BX and not XB. So we're going to do the same thing here. Think of it as two couples dancing and they're switching partners. So now what I'm going to do here, I'm going to crisscross Na and Cl. Since one is +1 and the other one's -1, I'm going to get NaCl. Now when I crisscross the other two, remember copper being the metal goes first. I'm going to crisscross it with hydroxide, and you need to put the hydroxide in parentheses and you get copper 2 hydroxide. Now this is the complete molecular equation, but one of the things you got to do is check to see if it's balanced. So notice there's 2 chlorines on the left here, so I'm going to add a 2 here in front of the NaCl to balance the chlorines. And then what I'm going to do here is after I put that 2 in front of the NaCl, that means I need to put a 2 here to balance the sodiums. Now notice I have 2 oxygens and 2 hydrogens, and I have that over here as well. So my oxygens and my hydrogens are balanced, and I have 1 copper on each side. So this would be the complete ionic equation. Now what we're going to do, we're going to take it a step further. So this is the answer to part A. We had sodium hydroxide reacting with copper 2 chloride, and we know that we made sodium chloride and copper hydroxide, copper 2 hydroxide. Now, one of the things we're going to do is we're going to use the solubility rules. And if you look here, notice where sodium is. Sodium is an alkali metal. So any compound containing an alkali metal, it's soluble. There's no exceptions. So this has an alkali metal, and so does this one over here. So both of these are soluble. When something is soluble, we're going to put AQ for aqueous. So that rule tells us that both of these are soluble. Now, let's look at copper 2 chloride. When you look at the copper 2 chloride, chloride is a halogen, and halogens are soluble with almost everyone except with silver, mercury, and lead. Copper is neither one of those. Therefore, this compound is also soluble. Now let's look at copper 2 hydroxide. Here's hydroxide. We can use this rule. According to the rule, usually these are insoluble. unless hydroxide is with an alkali metal. Well, copper is not from group 1. Copper is not ammonium, and copper is not one of these elements here, calcium, strontium, or barium. According to the rule, since hydroxide is with copper, it will be insoluble, which means it's going to be a solid, and that will be our precipitate. Okay? Now remember, we had balanced this earlier, so let's keep the 2 here, and let's keep the 2 here. And we have answered part A, which is to write the complete molecular equation. Now here's what we're going to do. We're going to use that to write what is called the complete ionic equation. So in part B, what we're going to do is anyone here that is aqueous really is not together as a compound. They're basically split up into ions. So what's going to happen here is NaOH is aqueous, so we're going to split that up into sodium ions. Let's put a plus sign between them, and hydroxide ions. Now we got to keep track of how many. There's a 2 here. That means that when it splits, you make 2 of each, so you have to put a coefficient. Okay? Now, copper 2 chloride is also aqueous. So we're going to split copper 2 chloride. Well, let's put a plus sign here. When copper 2 chloride splits, it splits into copper, which is plus 2. Another plus sign here. And it splits up into chlorine, which is minus 1. Now, notice when it splits, there's 1 copper for every 2 chlorines. So we're going to leave copper with 1, but we're going to put a 2 here to keep track. Okay, so notice copper 2 chloride splits in a 1:2 ratio. Now let's do the other side. NaCl is also aqueous, so we're going to split that into sodium as well as chlorine. And since there's a 2, we're keeping track of how many, so you got 2 of each. And then here's the interesting part. If you have a solid, a liquid, or a gas, you don't split up. Only aqueous gets split up. So what's going to happen here, copper hydroxide will stay intact. Okay, let me see if I can write that a little lower so you could see it better. So let's put here a little plus sign, and let's put copper hydroxide. And we know it's a solid. It doesn't split up. In fact, that's our precipitate. I'm going to go ahead and label it so that we got a precipitate there. The precipitate is the definition of a solid. Now, there are no solubility rules for ions. Ions are always aqueous. So all of these guys here that you see that have a charge, you don't need to look at a solubility rule. They're automatically aqueous. So look what I'm going to do. I'm going to label each one, and I want you to do this. This is a formality. Okay, these guys are ions that are freely floating in water. So all ions are automatically aqueous. You don't need to consult a solubility chart. So what we just did is called the complete ionic equation. Now, I'm going to transition to part C, and I'm going to show you something called the net ionic equation. And while I do that, I'm also going to define what a spectator ion is. So here's what we're going to do. I'm going to use part B to give us the answer to part C. In part A, we were looking for the molecular formula. So, or the molecular equation. In part B, we were looking for the complete ionic equation. And now we're going to get what is called the net ionic equation. Here's how you get this. If you see something on the left side of the arrow, which is the yield sign, and it's exactly the same as on the right side of the arrow, we are going to cancel them out. It's kind of like in math. If you see 2x plus y is equal to 4 plus 2x, then you know that since these are identical on opposite sides, they cancel out. And that's the idea behind this. So let me take you through this. We're going to look at part B, at the complete ionic equation. And do you see someone on the left that's exactly the same as on the right? Now, if you notice, I see that sodium over here and sodium over here are identical. So notice how I crossed them out. Okay? When you look at hydroxide on the left, it's copper 2 hydroxide on the right. So you can't cancel that one out. Same thing with copper. You don't see a copper on the right side. However, the 2 chlorines here have 2 chlorines on the other side. So notice I've crossed out 2 species. I crossed out sodium ions and I crossed out the chloride ions. The guys that we just crossed out, you're going to hear that these guys are called spectator ions, which is actually the answer to part D. Okay, they're called spectator ions. And the way they got their name is that they're spectators. Like in a sporting event, a spectator is someone that's sitting on the sidelines. They're watching the event, but they don't participate. Notice that sodium is the same before the reaction and after the reaction. Chlorine is the same before and after. They didn't do anything. They stayed the same before and after. They did not participate in the reaction. Therefore, that's what we call a spectator ion. So then what is the net ionic equation? The net ionic equation is when you remove the spectator ions and you bring down what remains, the resulting formula is the net ionic equation. Now, I always like to put the metal first. So I'm going to put copper here first. Okay? I'll put the non-metal here, which is the negative one. So notice I am not writing the spectator ions. That's how you transition from the complete ionic equation to the net ionic equation. You just don't write the spectator ions. And what the net ionic equation does, this actually is what drives the reaction. The fact that we're making a precipitate, which is the solid copper 2 hydroxide, this is the reason why this equation proceeds. Okay? So the net ionic equation is really describing the real chemistry which is driving this reaction. And the spectator ions are the ones that don't participate, which is sodium and chlorine. All right? So those were the solubility rules we used to determine who was the precipitate. And here's a summary of everything I did step by step. So when you have a problem like this, you have to convert first from a word to formula. And if you recall, that's, you got to know that sodium's +1, hydroxide's -1, so you can crisscross and get NaOH. You got to know that copper is +2. You can, figure it out from the name because it was copper, Roman numeral 2 chloride. And when you crisscross, you get these guys. And then you do a little FOIL. And that's how you get the two products over here. And then in step 3, we see how we added the coefficients to balance. And using the solubility rules, we were able to determine if it was aqueous or a precipitate. This is the abbreviation for precipitate, which is just a solid. So the molecular equation is what you're seeing right here. Then all the guys that are aqueous were split up into ions. And if you notice, we split up NaOH, copper 2 chloride, and NaCl into ions. We kept track of how many are made as they split. Notice that a coefficient goes to both. So when NaOH split, you made 2 of each. There is no coefficient in front of CuCl2, but when it splits, you make 1 copper and you put two chlorines. Notice you don't put a subscript. When you split them, you use coefficients to keep track of how many ions are being generated as they split. NaCl, there's another coefficient, so notice we got two of each. And then again, you can't split a precipitate, so it stayed intact. So that is the complete ionic equation. We know our precipitate is copper 2 hydroxide. And then the next step was to remove the spectator ions. Okay, so that's what we did. We crossed them out here. And when you remove the spectator ions, the remaining ions and the precipitate is called the net ionic equation, and that is what drives the reaction. Okay? So hopefully this is a good tutorial on how to write a molecular equation, a complete ionic equation, and a net ionic equation.